This will be a talk about how AGL enables developers to create web applications for the platform, the architecture needed to make it work, how to create web apps for the platform, and how we can expose system services to web apps, and an update for our plans for the web application support on AGL. Here is just a little agenda with the topics for today. So, hi, I'm Roger. I work at Igalia, mostly working on Chrome OS projects and also on AGL, working on supporting WAM and web applications for the demos. And Igalia is an open source consultants based on Galicia in Spain. We have more than 100 engineers over the globe, and we have experience with web rendering for Chromium, WebKit, and also other open source projects like the kernel and JavaScript engines, graphics, multimedia. And we are the second main contributor to Chromium, right after Google, and the second main contributor to WebKit, right after Apple. And to understand how web support works for AGL, we should start with WAM. WAM stands for Web App Manager. It's based on the Web App Manager from the WebOS open source project. It's forked to AGL and adapted to the project needs. It's a runtime that runs and manages web applications, manages the lifetime of the applications. It's not framework specific. You can develop applications using any front end that you want, even React or Flutter or Tailwind CSS. I have a small demo at the end of the presentation that uses Tailwind CSS. Because it's based on Chromium, we have out-of-the-box compatibility with the standard web APIs. And the web standards move fast, so we need to constantly upgrade Chromium, and on each update we get support for new APIs, and they are available for developers on the AGL platform through WAM. Like I said, it's built on top of the Chromium from the WebOS project. This means that we are tied to the release cycle. Every time they release a new Chromium version, we need to fork it and apply changes on top of it to ensure that it is compatible with AGL and make it work with the AGL platform. It manages the life cycle of applications, like launching, terminating, suspending, and bringing the applications back to front. There's some CPU usage, optimization, and memory management implemented on the WebOS Chromium fork that one takes advantage of. And how does it work? This slide is actually stolen from my colleague's talk at FOSDEM. I welcome you to watch it. It's a talk about the history of WAM, how it works, the architecture, and where it's used. It's a pretty good talk. So this diagram shows how it works for the WebOS platform, but it's pretty similar to what happens on AGL. So WAM spreads across two different processes, the browser process and the renderer process. On the browser process, it handles calls that comes from the renderer process and actually communicate with system services. And this is done by a small library from the WebOS implementation that allow us to add some pluggables. In the case of WebOS, for example, there's the Luna bus that it's injected on the renderer process, and the main service is hosted in the browser process. But in our case, it's the gRPC server and clients for internal IPC. And one also takes advantage of the Ozone Wayland implementation that was done by Igalia on Chromium, and it communicates with the AGL compositor to be able to render surfaces. Okay. So this is the main screen of our HTML5 demo, and what happens is that when we start the image, it launches multiple WAM processes. The first process will be responsible to communicate with the AGL compositor, and all the other processes will launch and manage applications. Like on the left side, that panel is the home screen application. On the right, it's the launcher application, and each icon is also HTML5 application. When we click on an icon, another WAM process will run, and it will be managed by the main process. And these are all the demos that are present on that image. If you go to the automotive Linux Garret, you can filter for HTML5, and you will be able to check the code for all of them. And as an example of how we leverage from the Chromium architecture to communicate with system services, I can show how it's implemented, how the infrastructure to launching application is implemented on WAM. The first architecture slide is basically the right side of this one in simplified version. libcbe, it's a library compiled from the Chromium code that's used by WAM, and WAM communicates with uplaunchd to launch new applications. Uplaunchd starts new application by starting system services related to the installed applications, and WAM communicates with it using dbus and gRPC in the future. And those are the two classes I'm going to talk about more in the next slides. Like I mentioned before, one spreads across the browser and renderer process. The app service delegate AGL, it's the server class responsible for receiving calls from the renderer processes. And AGL app service injection is the code that's injected in the JavaScript context for all WAM applications. And let's say we have a list of applications, and this template that renders the icons and allows the user to start, and that's code actually from our home screen application. We want to use this start function and be able to start new applications. So these are the names involved injecting the application service interface on the JavaScript context. The navigator is the object that the browser exposes with information about the browser itself. App service is the name of the application service that we want to access, and I'm going to talk about only the start function that will be responsible to start new applications. This is the code that injects the call to the start on the JavaScript context. The isolate is actually the V8 context that's available on every renderer process. Every renderer process that has a different one, and Gin is helper library that makes it easier to interact with the V8 JavaScript engine. And here we are only creating a new object that has the start call and setting it to be member of a parent. And here is the parent. The parent is the navigator object. So we basically get a reference to this navigator object and inject our new object, the app service, into this object. And on JavaScript, we will be able to access a navigator.app service. But we need to be able to make a call. So here's another helper function from Gin library. Here we assign to the start function the method from our injected class. So this class will communicate with the service on the browser process. This is done by using Mojo. That's the IPC library that's used by Chromium. And this call on the render process will be serialized, transferred to the browser process, and deserialized, executed, and the browser will return some value to the render process. And on the browser process is where actually the communication with app launchd happens. It receives the call, sets all parameters needed to do a call using the dbus proxy that is connected to app launchd, and it passes the arguments to start the new application. And so with this, we are able to write this function, and this application service will be available to all running instances of WAM. So you can access the web services, the application service, regardless of the framework that you use to build your web application. And so let's talk briefly about how we can clone and build the AGL HTML5 image. We need that to be able to understand how we can include a new application. So there's this getting started guide on the AGL wiki. There you can check all the supported boards and all the instructions for starting up. But basically you need Google the pod tools to be able to clone all the repositories, and here's the command that you can use for building the HTML5 image for your target architecture. So you can build for Renesas, for Raspberry Pi or QEMU or other platforms. And when you run that command, actually you build two different recipes for for the HTML demo. One is the Chromium recipe that will get the code, the whole code from the WebOS Chromium fork and build the libcbe that will be used by one, and one creates the runtime that will be used by the platform to launch new applications. And here's how you can flash it to test on your hardware. It's pretty straightforward. Then you can just boot in the board that you are using. And now I can speak about how you can create a new web application for the AGL web platform. So here's what's needed for a web application. You need to create an app.info JSON file that contains some metadata, like the name of the application and the type of the application that will be run. That would be web in this case. A directory with the code of your application containing a license file that's needed by Yocto. And like I mentioned before, there's no dependence on any framework. You can develop your web applications any way you want. And first, you need to create your directory, add your source code and the license file, this app.config file I mentioned, and you need to create a new recipe for your application and add to the AGL tree. Before the recent app framework changes, where the app framework was deprecated, it was possible to just copy a bundled web application to the image and install it using AFM U2, but this tool is not available anymore, and right now the only way that we can use for adding a new application is to put it in the AGL tree and bake a new image. And as an example, we are going to make an application that just starts up and redirects the user to the Jamendo main page. It's just a music service for independent artists. And this is the app.info JSON file, contains some metadata, and the most important ones here are the ID, title, type, and the main file. That's the main HTML file that will be loaded when one starts managing this application. And this is the main, the index HTML page, just redirects the user to jamendo.com. And here's where we start to build our recipe for the new web application. For this example, we can call it HTML5 Jamendo Git, because I created the Git repository on GitHub for it. And here's just the basic information. There's more information on the Yocto guides about it. You can set the home page, a few build directory options here. And after that, you will need to set up the fetcher that's going to get your code. In my case, I hosted the demo on GitHub, but it's also possible to use other fetchers like SCP, local files, and there's the external source option that can be used, and you can point to a local directory where you're building your image, and this is good during development, because you don't need to commit your changes and get everything and bundle again. And this is how you set up this option that I mentioned. You need to change your configuration files indicate that you're using the external source recipe, and just point to some file and to some directory with your code and build the image again. And finally, we can set up how the application will be installed. We need to tell it that it's going to use the template for AGL web applications. This is going to make it use the generated systemd files that use WAM to start this application and point to the correct directory. And on the install here, you can, for example, if you are using other frameworks, call npm install or wherever your web application needs to be built and deployed. And after creating the folder with a new application, you need to add it somehow to the AGL tree. And you can do that by adding it to the package group of the HTML5 image. So you have just a list of applications here. You just need to add the new directory that you created, and then the next time you bake your new image, this new application will be added as well. And one option to test your applications is to use QEMU. Here is the command that you can use after running it. You can connect to it using any VNC client. And this is the demo application that I showed running on QEMU, and I'm connected to the QEMU image, the running image using VNC. Anything that's available on Chromium for debugging and inspecting your source code is also available for AGL. You just need to do some extra setup to redirect to the correct ports. Here's the export that you can use, and for doing that, and after running the QEMU again, you can connect to the to your image. And here's an image of the remote tools connected to the sample application. You can inspect for style and scripts and anything that's available on Chromium for debugging and inspecting your running application. And currently we have some options to interact with services in AGL platform, and most of the demo applications are communicating with Cuxa Vol server. If you want to know more about Cuxa, there were some nice presentations about it yesterday. You can check the recordings. And on web applications, you can create a WebSocket that's part of the standard libraries shipped with Chromium to connect to the listening port of the Cuxa Vol server. And I included this demo that connects with Cuxa. The current HVAC application is already communicating with Cuxa server, but I decided to keep this one because it uses a different framework for web. It uses Tailwind CSS, and also if you want to understand how communication is happening, there's a little text box that shows the messages that are going and coming from the server is good for understanding how the communication happens. And this is how you can connect to the Cuxa server. You basically set up a new WebSocket and authorize and set up which signals you are subscribed to. This out token is a JSON web token. On the demo platform, we use the super user token that's shipped with Cuxa. It's enough for testing. And the other parameters that are on this slide, like the request ID, they are user-defined parameters. Request ID, you can set an ID that it's going to be sent to the Cuxa server, and when you receive a reply, we can compare the values to know which response is assigned to the request you made. And I added a few links with documentation for the Cuxa Vault server and the specs of the signals that you can access. And here's how you can subscribe to a signal. After doing that, you will start receiving message from the server, and when you receive something on this WebSocket, you can just check for data and see what you received. That's how we implemented it on our demos. And just a couple of helper functions to get a value from some path on Cuxa, or set values. And here's where you can access all the sample code that I added in this presentation. This is going to help to understand how you can add new applications. And speaking about our future plans for the AGL web support, we plan to upgrade to the new Chromium milestone that was shipped by the WebOS project. That's milestone 94. We plan to improve how the applications are deployed. Currently, the only option is to add a new recipe and bake a new image. We are planning to make it easier, like adding bundled applications again. We need to bring back Chromium as an application in the new images. It's not working because, if I'm not mistaken, it wasn't ready to work with UpLaunchD. Another plan is to make it possible to use gRPC on the web app side. We already have gRPC server and clients implemented in Chromium, but we can't, for example, use a proto file from the Cuxa project and generate code that can be used by the web applications. And this is because gRPC web needs a proxy server running on the AGL platform, and we need to check what would be the best option for that. And we need to update Chromium to communicate with UpLaunchD using gRPC. Right now it uses dbus, and dbus is going to be deprecated from UpLaunchD. And one thing that we are going to do is to experiment with CEF instead of Chromium from the WebOS project to build WAM. And about CEF, we think that it brings a few advantages to the process. It's easy to switch to a new branch. Every time a new branch is released on Chromium, a new milestone branch, the same branch is created on CEF and maintained there. We would not have dependence on the Chromium Web OS release cycle. It takes some time to release a new version. For example, we are using Chromium 91, and the next one would be Chromium 94. We would be able to switch faster to new branches and get updates with new features and security updates, for example. And CF is usually only a week behind of the released Chromium branch because they need to manually maintain it and apply any fixes. And that's it, basically. We have our contact information of the 3 Igalians most involved in AGL development. You can contact any of us if you have any questions. And yep, that's it. If anyone has any question, I think we have some time. All right, seems like no, so I think we can close it. Thank you.